These next couple of problems will involve quadratics situations with context. So in this case, we're looking at a diver, and we have our x-axis and we have our y-axis, and so we have h for height and t in seconds. So the x-axis is time in seconds, and the y-axis is height in feet. So about right here, we're looking at about 70 feet, and that diver jumps, and we're just trying to find the maximum height of the diver, and we know that that's going to be 70 feet. When does the diver strike the water? That's going to be a solution. We know it's going to be at this point right here. And then we also want to find how long it takes for a diver to be about 30 feet. So if here's 70 feet, maybe somewhere around there would be about 30 feet. So we're just trying to figure out on part C how long it would be in regard to time. So part B asks for when does the diver strike the water. So when the diver strikes the water, this is an x value and y is 0. So we're going to substitute y for 0 into our equation. And since this is negative, I'm going to add it to the other side, take the inverse, so I get 16t squared equals 70. I'm going to divide both sides by 16, and when you divide 70 by 16, you get t squared is equal to 4 375 thousandths. Well, I want t, not t squared, so I got to take the inverse of squaring, which is the square root. And I'm going to take the square root of that answer, and I get about 2 900 seconds. So just a little over 2 seconds is when that diver would hit the water. The next question, part C, asks, well, what if it's 30 feet above? So it's not 0 where it hits the water. It's going to be 30 now. So 30 feet, not 0 feet, into the equation. So I'm going to add the 16 to the left side, and I'm going to subtract the 30 from 70, and I'm going to get 16t squared is equal to 40. And I'm going to divide both sides by 16, so I get t squared, and 40 divided by 16 is 2.5. Well, I want t, not t squared, remember, so I'm going to take the square root of both sides. So t is equal to, the square root of 2.5 would be about 1.6 seconds, approximately. What does this answer mean? It means a little more than a second and a half for it to be about 30 feet above the water. So the answer to part C is an evaluation, or it's a substitution into the equation to find the value. Question 2 is a situation where we're launching an object. And so the graph is going to look something like this. And we know it's going to hit the ground somewhere over here. So in our equation, we have the a value, which is -4 9/10. That's causing this to curve or open down. We have a y-intercept, which is almost 59 feet, so 58 9/10 feet. So notice when it's launched, it's going to hit a peak and it's going to come down. I want to know the solution. I also want to know the height of this, which is the axis of symmetry, and the vertex. So I'm going to do these kind of out of order. I'm going to work part B, and the vertex is an equation. Well, let me back up as well. Let me find the axis of symmetry. So the axis of symmetry is x equal -b divided by 2a. The axis of symmetry is the x component of your vertex. And the axis of symmetry is going to be a vertical line that divides this into two symmetrical pieces. So it's going to be somewhere, just with my sketch, ballpark it, it's going to be somewhere right in here. Now, what I need is the A, B, and C from the equation. So x equals negative b. Well, b is 19.6. So negative 19.6 divided by 2 times negative 4 and 9/10. So what does that give us? Well, we're going to get, when we take negative 4.9 times 2, we're going to get negative 9.8 in the denominator. And now we want to divide these. And when I divide negative 19.6 divided by negative 9.8, you get x equal 2. So what does that mean? Well, that means on the x-axis, which is time, about 2 seconds is when this object has reached its peak. Well, what you can do is then into your equation, especially using your calculator, is you would substitute 2 wherever you see a t, and you find your result. So negative 4.9 times 2 squared, which is 4, plus 19 6/10 times 2, plus 58 8/10. And when you compute all that, you get about 78 4/10 feet. What does that mean? Well, that's your vertex. At 2 seconds, this object is about 78 4/10 feet up here. There's your vertex. What's your axis of symmetry? It is the x part of your vertex, and that was your x equal 2, which we found from this equation. So we found the axis of symmetry, which we substituted in to our original, and we found an output of 78 4/10. So we found our vertex. Next, I want to know, when does the object strike the ground? So that's part A. And what we're going to use in this situation is we're going to use the quadratic formula. And we're going to substitute. So A, we know to be negative 4 9/10. And where do we get that? We get that from our original equation, negative 4.9. B is 19 6/10, and C is 58 8/10. I'm just double checking all my numbers from my equation. 58 8/10, yes. 19 6/10 for B, and negative 4.9 for A. So we're just going to substitute. So x equal negative 19 6/10 plus or minus the square root of 19 6/10 squared minus 4 times negative 4 9/10 times 58 8/10. All divided by 2 times A. So let's continue to simplify. So what am I going to get as the radicand? Well, I'm going to get 19 6/10 squared, and that's going to give me 384 1600ths. Now notice I'm subtracting, but what am I subtracting? I'm subtracting the product of 4 and negative 4.9 and 58 and 8/10. So that product is negative 1,152 and 48/100. And that's all being divided by negative 9.8. So what do I get inside the radical? Well, that would be 300, and this is going to be subtracting a negative, so that's going to allow me to, just so we can see, that's going to allow me to add those together because I'm subtracting a negative. So 384 1600 plus 1,152 and 48/100 gives us 1,536 and 64/100, all divided by negative 9 and 8/10. So let's go ahead and find out what the square root of that answer would be. And that's going to be plus or minus, the square root of this value would be 39 and 2/10. So here's what I have with the quadratic formula. Now I have two situations. I've got an addition part and I've got a subtraction part because that's coming from your values here. So I'm going to have negative 19 and 6/10 plus 39 and 2/10, all divided by negative 9 and 8/10. And I'm going to have negative 19 and 6/10 minus 39 and 2/10, all divided by negative 9 and 8/10. So remember, this is x equal, this is x equal. So what am I going to get here? I'm going to get negative 19 and 6/10 plus 39 and 2/10 divided by negative 9 and 8/10, and I get negative 2. So negative 2, 0 is one solution. This one is negative 19 and 6/10 minus 39 and 2/10, and then divide by negative 9 and 8/10, and I get x equals 6, or 6, 0. So what are the two solutions? They're right here. And what does this mean in context? Well, in context, it meant that right here is where the dive, or where the object hit the water at 6 seconds. This was at 2 seconds, and that just means that way over here is that negative 2 seconds, which we don't care about because we're only looking at a positive amount. So we have two solutions, but only one makes sense in context. So it will take 6 seconds to reach the ground.